Okay, so this video is going to review exponents and logs and trig. We're going to work on the 1 to 100 worksheet. We're going to start with the number 1. Anna and Zach each have $600 to invest. Anna earns 10.5%. Zach earns 6.5%. Approximately how much more money will Anna have than Zach when Zach's are worth $900? So here we go. Anna and Zach. Anna, let's see, we're compounded continuously, so we're pert. So she has $600, 10.5, so 0.105, and we don't know her T. So this is her amount. And then Zach's amount, he's starting with $600. No, not equals. He's starting with $600, and he's at 6.5%. I want Zach's to be worth $900, so I want this to equal 900. You could do this one of two ways. You could plug it into your calculator, into y equals, and do 600 e to the 0.065x start at 0. We'll try going up by 1, see what it looks like. I want him to be worth 900, so happens somewhere between 6 and 7. So I'm going to go to my table set, and I'm going to start at 6, and I'm going to go up by 0.1. Again, I'm looking for it to be 900. 6.3-ish. You could go one more if you wanted to, and start at 6.2 and go up by 0.01. And you can see that it's right there, 6.24. The other way you can do this is to actually solve it. If you just divide by 600, that's going to give you 3 over 2 equals e to the 0.065t. And then if you just ln and snail it, so ln base e of 3 over 2 equals, and then just divide by 0.065, you're going to get 6.24 years. So Zach has $900 at 6.24, so now I need to see how much Anna has. So again, I'm going to grab my calculator. 600 e to the 0.105 times 6.24. So she's got 1155.32, and he has 900, and I just want the difference of that, so I just subtract, and it's 255 and some change. The next one we're going to look at is number 2. Solution's pH is given by this function. So this is the pH, and T is the concentration. We have a pH of a 5, so that goes here. And I'm solving for T. So first I'm going to divide by negative. And then you need to remember that this is base 10. Any log that doesn't have a base is base 10. So then I'm going to snail it. So 10 to the negative 5 equals T. And that gives me that. And that's just typing it into your calculator. Value of, okay, so now we're going to do number 3. And the value of account compounded continuously, so we're PERT, is given by, and I want it to double. So if I start with $1, I want to end up with 2. You could have done, I want to end up with $100, so I'm going to start with 50. Regardless, when you divide by 50, you're going to get a 2 over here. So any amount of money you start with here and double it here, you're going to end up at this equation right here. And then again, I'm just going to snail it. This is in E, so I'm going to ln base E of 2 equals 0.024. T, so then I just type in ln2 and divide it by the 0.024, 28.88. Practice typing that in on your calculator. Make sure you're good with that. The next one we're going to is number 5. Which function results in the shifts? We're going to go left 4. So that's in here. Left 4 would be a +4. And down 3, so that would be a -3. So that's going to end me up with a +7 and a -9. And again, this x plus 3 is inside my function, which is an ln. Okay, now we're headed to number 18. Number 18 is the condensing. 3 becomes a power on the x, and that's multiplication, so it's going to be x to the 3rd times 2. And then this is going to be division. That one. Okay, now we're headed to 31. Okay, compounded continuously, we're investing $6,000. We are earning 6% interest. And I don't know my time, but I know I want it to be worth $25,000. I'm just going to divide by 6,000. That's going to give me 25 over 6. And then I'm going to snail it with an ln. So ln of 25 over 6 equals 0.06t. And then I just do ln of 25 over 6 and divide it by the 0.06 to solve for t. And you get that one. So just be super comfortable with snailing it. 31. Now we're headed to 47. Okay, let's snail it. 3 to the 2nd equals x minus 4. And that's a 9. And add 4. That's a 13. And now we're going to 55. Inverse. Switch the x and the y and solve for y. Now, this right here is all being logged. So I can't add 1 and divide by 2. I have to snail it first. So 5 to the x equals 2y minus 1. And then to solve for y, I'm just going to add the 1 and then divide by 2. So 5 to the x plus 1 over 2. Okay, now I'm headed to 70. For another inverse. So that's this one. So I'm gonna flip-flop my x's and y's. I'm gonna subtract the 4, and then I'm gonna log both sides. So log base 1.5 of the x minus 4 equals the y. And that's not a choice. And this is where you really need to know the tall small. So log of the tall over log of the small. See? Again, just know how to snail. 78. 78 is one where there is a method for how to solve it. But for something so simple like this, you could just plug in answers. Take this and plug it in for x and see what you get. Or you could plug this one into your y1 and this one into your y2. And on your chart, find where these two are the same. It happens at D. And they're pretty dead on it. So these would be your x's. These would be the numbers in here. So you would need to go to your table set and go 3 decimal places. So your delta x would need to be 0.001. So you get to see all 3 decimal places. And then you just need to go check out those 3 decimals or those 4 places on your x's and check out their y's. All right, and now we're headed to 87. Okay, it gives me the formula. T is temperature and X is pebbles in the tank, and I want the pebbles when the water is 58.3. Oh, not equals. Okay, so I'm going to subtract the 52.4, and I get 5.9. Okay, this is a log, so I'm going to snail it. His base is in E, so E to the 5.9 equals 1 plus X, and then I'll just subtract the 1. So X equals, you just type it in, E to the 5.9, and then minus 1, and you get 364.04. So, A. And then 88. This is exponential. Normally this is where we would just log it and snail it, but he's kind of quadratic. So you need to think of him like a trinomial. Now make sure it's e to the x and e to the x, because when you multiply that, you add your powers, and that's where the e to the 2x comes from. 12, I'm going to try 4 and 3. I'm trying to get a 5. Yeah, that would work. 4 and 3, because that's an 8 and a 3. I want a positive 5. So positive 8, negative 3. And then I set these equal to 0 and solve them. And then you've still got to remember how to snail it. Because this is an E, I'm going to ln it. So ln of 3 over 2 equals x, and that's just doing the snail. And ln of negative 4 equals x. You cannot log a negative number. If you type in your calculator, it'll tell you that it's an error. So just keep that one. Okay, that's it. That's it for logs and exponents. So now we're going to go back and do trig. So we're going back to number 8. Water tower, y'all are really good with the right triangle trig stuff. Just take your time on your drawings and make sure that you understand how everything is labeled. I got a water tower in a building, then I've got a window in the building. It is observed that the angle of elevation to the top of the tower from the window, so from its line of sight, is 42 degrees, and the angle of depression, now that's from your line of sight down to the bottom, is 25 degrees. And I want to know how tall the water tower is, so I've got to do this in 2 separate right triangles. He's 410, so I'm just going to do tangent. So tangent of 42 degrees equals opposite over adjacent. Make sure you're in degrees. Multiply both sides by 410 and get 369. Pause this, take your time, type it in, make sure you're good. And then I'm going to do the other one opposite over adjacent. So then I know both these pieces, and then I add them together and I get the whole water tower, which is 560. Next one is number 9. We struggled with number 9. And when I graded stuff, a lot of you didn't even have a graph there. I highly recommend just kind of plotting these points. I can see that my y values fluctuate between a 0.5 and a negative 0.5. So I know that my amp is a half, so it can't be him. At pi over 2, I'm up here. So I know that I'm going to do this because I know what cosine looks like, and all of these are cosine. And I can see that I'm shifted right pi over 2. So I just have to find, remember, it's the bx plus c set equal to 0. That's your shift. And if I take him and set him equal to 0, I would add pi and divide by 2. That would give me a positive pi over 2. That's what I want. I want to shift to the right pi over 2. So that's 9. Now we're looking at 10. How does the graph differ? Well, that's going to squash it. So amplitude is smaller. So these are out. And this, normally the period's 2 pi over b. This one's going to be 2 pi over 1. So his period's going to be a 2 pi. This one's going to be 2 pi over 2. So his period's going to be a pi. So the period for this one got shorter than this one. So A. All right, now we're headed to 12. And I think we're really good on these. Your law of cosines, when you've got two sides in the included angle, those two minus cosine of x, you need to stop and type this in and make sure you're good. You're going to type in 10 squared minus 5 squared minus 6 squared. You're going to get an answer. You're going to take that answer and you're going to divide it by parentheses, negative 2 times 5 times 6. Get an answer, and then you're going to cosine inverse that answer. But please take your time and type that in. Make sure it's right. If it also said that x was obtuse, and this angle turned out not to be obtuse, do you remember how to fix that? To make an angle obtuse, you just subtract it from 180, if that were to ever pop up. Number 13, these awesome Ferris wheel problems. I want the max height. I just want to know how tall it gets. Well, I can already see that I'm shifted up. Here's 0. I'm shifted up 60. So sort of like its center is at 60. And then I can see that my amp is 55. All the negative does is mean that it's going to swing down first. That's fine. But it is, so it's going to go down 55. And it's going to go up 55. So it's going to come down within 5 feet of the ground, but it's going to go up to 115. The shift shifts the center of gravity of this thing. So it's going to do that. That's the 60. Okay, 14. I'm trying to go as fast as possible, so this is a quick review and not an hour-long video, which it probably will end up being, but just knowing that you're going to pause it whenever you need to. This wants range. Range is wise. Let's see, we're shifted up 12, and my amp is 8.5, so I'm going 8.5 that way, and 8.5 that way. 12 plus 8.5 would be 20.5. And 12 minus 8 would be 4, and then another half would be 3.5. So he's going to go up to 20.5 and down to 3.5. Now I'm headed to 16. Let's see. We have a diameter of 80. So I know that my amp is 40. And honestly, that's all you need. Fighters enter the Ferris wheel at the lowest point 5 feet above the ground. One complete rotation. Yeah, because if my amp is 40 and I've shifted up 45, if this is 0 and my center is shifted up 45 and then I go up 40 and down 40, wouldn't that put me getting on 5 feet above the ground? So that makes sense. But honestly, the diameter being 80 shows me that if this is my center, I got to go up 40 and down 40. So my amp has got to be 40. Okay, headed to number 20. I want an amplitude that's twice that, so that'd be a 6. And a period that's 3 times. Okay, now this is the one where I think most people chose this one because they see that the B has been multiplied by 3. But remember, period is 2 pi over B. So right now for this guy, his period's in 8 pi. So what I'm looking for is a period that's 24 pi. If you take this one, again, period is just 2 pi over B. Doesn't have anything to do with the C. Just 2 pi over B. If I Bojangles that, that gives me 8 pi over 3. That's not 3 times that. That's actually cut into a third. But if I take this one and go 2 pi over 1/12 and then multiply by 12, I get 24 pi, which is 3 times the original 8 pi. So there's number 20. Okay, now we're going to go to 21. Okay. So this is the original. That's the origin. So this, let's see, from here to here, so an amp of 2. So this has got to be my center. Okay, if my center's supposed to be here, he was shifted up 4. And all these have a plus 4. Amp is up 1, down 1, so all my amps are 1. That doesn't help me at all. You've got to remember that a sine, 2 full humps, cosine, 1 full hump, 2 half humps. Now it's just all about the shifts. This one's going to be a sine, so that's this one that shifted. If I set that equal to 0 and solve it, that's going to go right pi over 3. If I look down here at the bottom, there's 1, so pi over 3 would be roughly there. So yeah, I'm kind of digging that one. Yeah, I kind of like that one. This one would be a sine shifted left, so that would need to do that, and it doesn't. This is a cosine. Let me erase some of this. This is a cosine shifted right pi over 3. So that would be, you know, about here. But remember, cosine starts up here and comes down, so that doesn't make sense. And this one would be left, but he's a cosine, so he would start up there. So both of these are out. 23. Honestly, guys, y'all are so good at these. This is just going to be a common denominator. I'm going to give him a sine and give him a cosine. Sine squared plus cosine squared over sine cosine. And then I'm going to Bojangles. And that's 1. So I have 1 over cosine, which is secant. Where'd he go? Oh, he's not a secant. They left him as 1 over cosine. Sorry. I'm looking for a secant. 25, super easy. 14, 17, included angle 72, and I want this guy. So that's 14 squared plus 17 squared minus 2 times 14 times 17. Cosine of your angle. This one, to type this one in, you just type all that, exactly like you see it in one swoop. And then when you get that answer, square root it. And you get 18.4. Type that in. Make sure you're good there. Don't miss those. Go miss something hard. Don't miss that one. All right, I'm going to 29, which is literally the exact same thing. He's 10, he's 13, he's 55. I want that one. 10 squared plus 13 squared minus 2 times 10 times 13. Cosine of 55. Type all that in and square root it, and you get that one. 29. Now we're going to 32. Lamppost, 418 feet from a building. There's the lamppost, there's the building. Angle of elevation from the base of the lamppost to the top of the building is 32.3 degrees. How tall is the building? SOHCAHTOA, I'm going to tangent my 32.3 degrees, opposite over adjacent, multiply both sides by 418, 264.2. 32. Now we're going 38. This is a good one. 38. What is the range of the inverse? Range of the inverse is the domain of the original. Don't go find the inverse. Just give me the domain of the original, okay? For the original domain is x. So think about tangent, the graph of tangent. Where were these asymptotes for tangent? They are negative pi over 2, pi over 2, and 3 pi over 2. Those are asymptotes. That's what you can't be, so you need to be in between them. Then I think the one I gave you was cotangent, and those are 0 pi and 2 pi. So the range of the inverse of the cotangent would be in between those two. 39, I feel like we're pretty good on this one too. We've got James and Samantha, and they're 10 meters apart. We got a bird. James is looking up to the bird at an angle of 74. Samantha's 47, and I want the bird to Samantha. I'm gonna... I can't law of cosines because I don't have two sides and an included angle. I can't law of sines yet because I don't have an angle and a side. But if I know two of my angles, I can subtract them both from 180 to get him, which is 59. And now I have an opposite side and an opposite angle, so I'm going to use my law of sines. So sine of 59 degrees over 10. And I want x, so I'm going to use this one, equals sine of 74 degrees over x, and that's an equals. So then I'm going to multiply this, and then I'm going to multiply that, so I'm going to end up dividing by him. So 10 times sine of 74 degrees, hit enter, and then divide it by sine of 59 degrees, and you get 11.2. And remember, law of sines and law of cosines is on your formula sheet. That was 39. Now we're going 41, which y'all are awesome at. One. Oh, yeah, so my answers are 1. So now I got to figure out which one of these is 1. Well, it's sine squared plus cosine squared equals 1. So no. No. Okay, so now I got to know the other ones. 1 plus tangent squared equals secant squared. The tangent and secant are on here. 1 plus cotangent squared equals cosecant squared. So for it to equal 1, I would have to subtract him over. So cosecant squared minus cotangent squared. That one. So that took something that's very easy and just made it annoying. So just be careful and know your trig identities, which are on your study guide. All right, now we're going to number 43, which is easy. $25 a foot, and I want this, and you can see that I have a side, and the included angle, so I'm going law of cosines. So the side I want equals 46 squared plus 28 squared minus 2 times 46 times 28 cosine of 80 degrees, straight up type all that in, square root it, and I got 49.5. And I'm $25 a foot, so I need to multiply that by $25, and I got roughly A. That's 43. Now we're going 49. I've got a base of a building, 100 feet. Look up, angle of elevation of 40 degrees. She goes 20 feet closer, so we're now at 80 feet. And I want her angle. What didn't change was the height of the building. So if I can use this one to find the height of the building, then I know the height of the building here, and I can use that to find her angle. So SOHCAHTOA tangent of 40 degrees equals x over 100, and multiply both sides by 100. Straight up type that in, and you get 84. So my building's 84, same building over here, so he's 84. I'm going to use tangent again, opposite over adjacent. Okay, pause for just a second. When you have nothing to tangent, and he is the angle, you tangent inverse the answer, and it will give you the angle. So tangent inverse, 84 over 80, and you get 46-ish degrees. 49. All right, now we're going 61. All right, we have a wall of a building. We've got a man. He's 50 away. Looks up at a window on the building. Angle of elevation up to the bottom of the window is 28.5 degrees. Then he looks to the top of the window. Okay, I'm going to draw another triangle. Top of the window, and it's 35 degrees. Distance between the top and the bottom. Okay, so I'm going to use this triangle and this one and find both their backbones and then subtract them. So tangent of 28.5 degrees equals opposite over adjacent. Multiply both sides by 50. And then I'm going to say he's still 50, so I'm looking for that. So tangent of 35 degrees equals opposite over adjacent. Multiply both sides by 50. And the difference between the two is almost 8 feet. 61. Now we're going 63. And we need to stop for a second and look at number 63 because of this. Okay. Now it says x is obtuse, so I'm going to let him be x. So I'm going to call him WXY. The angle is 14. The opposite of W is 7. The opposite of X is 9. And I want this guy. Okay, so I have a sine and an angle opposite each other, so I'm going law of sines. So sine of 14 degrees over 7 equals, I want this one, so I'm going to go sine of x over 9. So I'm going to multiply these two, and then I'm going to divide by 7. And I get sine of x equals whatever it is you get, and then you have to sine inverse that answer to get x. And I got 18.122. I want you to pause and type this in and make sure that you're getting 18.122. Make sure you're not just taking all that for granted. Then the problem is that that's not obtuse. So to do that, you just subtract it from 180. Every single time, you just subtract it from 180. So he's 161.88. So he is 161.88, which allows me to find this angle as 4.12, just subtracting from 180. So now I can use my sine of 14 over 7, 4.12 over the star, which is what I'm trying to find, and multiply and then divide by him. So your star equals 2.08. I'd stop and spend some time on that one. Love on that one a little bit. Make sure you're good with it. Okay, 65 is easy, but it's also easy to miss. Consider the two trig functions. How should it be shifted different? Well, the amp doesn't change and the vertical shift doesn't change. What changes is this. And a lot of people will look at this and say, oh, it's going to right, pi over 2. But your shift is the whole bx plus c. Now, the period did not change. The period in this one is 2 pi over 2, which is pi, and the period in this one is 2 pi over 2, which is pi. But the shift went from 2x equals 0 to 2x minus pi over 2 equal to 0. Well, if I divide by 2, this has no shift. But this one, if I add, that's a shift pi over 4. And it's positive, so it's going to the right. Oh, wait, not pi over 2, pi over 4. To the right, pi over 4. All right, now I'm going 76. And we only have 3 more to go. And again, we're really good at these. I would give him a 1 minus sign. So our denominators are the same, but watch out for the shark. So minus tangent plus tangent sine. And then I would go sines and cosines. So then I have cosine minus sine over cosine plus sine squared over cosine. And then I would give him a cosine. And then cosine squared plus sine squared is going to give me 1. But then I still have the minus sign. And then if I Bojangles, these are going to cancel and I have 1 over cosine, which is secant. And I'm going super fast through these because y'all have done 1,000 of these and you have this work because we've already done this problem. So if you need to, take your time and go back through it. All right, 91. 91 is easy. I need to simplify this. These are squares. Sine squared plus cosine squared over sine squared minus cosine squared. That's just factoring. Then these cancel, and sine squared plus cosine squared is 1. Know your trig identities. Know your Pythagoreans. All right, guys, last one, 94. Ooh. Okay, we go from 10 to 120. So from 10 to 120 is a distance of 110. So what's my amp? 55. So those are out. Then it says there's a minimum in 1964. Well, this is cosine, and it's flipped. So instead of doing this, it's doing this. So this would be its minimum. So its minimum, it needs to be right where it starts. And it needs to be in 1964. If I take this, hold on one second. Oh, let's do this. A cycle lasts 11 years. Let's work with that. If your No, the period's going to be the same both ways. If I did the period, 2 pi over 11, and you Bojangles, see how the 2 pi's are going to cancel and you're left with 11, and that works with this one too. So look at A and B and look what the differences are. This one is in your bx plus c. This one needs to be distributed. And if you distribute that, if I look at B. Okay, if you look at B, if I were to add 1964 over and then multiply by 11 and then divide by 2 pi, I wouldn't be at 1964, which is where the minimum needs to happen. This one is going to be, because you can leave this out because this isn't a part of the solving, and just take this guy and solve him. You were going to get a right 1964. That's going to shift him right 1964, which is where your minimum needs to happen. Okay, there's your logs, there's your exponential functions, and there's your trig. Logs and exponentials, you need to make sure you're fantastic with snailing, from exponentials to log and from logs to exponentials. With your trig, you need to be good with your law of sines and law of cosines, and you need to be good with the, not the wagon wheel, the Ferris wheel. You need to be really good with the Ferris wheel problems and shifting and periods and amplitudes and flipping. Just be really, really careful. And know your Pythagoreans, and you should be fine.